Awesome. So good afternoon, good morning, depending on where you are today. Thank you so much for joining us for this edition of Teraco Tech Day. My name is Yolandi. I am from the NAP Africa team, and we are joined today by Internet citizen Ben and Lee, and they will be taking us through monitoring and securing BGP on MikroTik Routers. So a very big welcome to our panelists. Guys, thank you so much for getting up super early to talk about MikroTik. I know you guys are super excited about this. So just for our attendees, guys, if you have any questions for Ben and Lee, please post them in the Q&A section. And you are more than welcome to engage in the webinar chat if you just want to say hi, or just say Ben and Lee is not awake yet, or you just, want to sell us stuff. I'm kidding. So yeah, guys, please, if you have, like I said, if you have any questions, please put them in the Q&A section at the bottom of the screen. And with that, I'm going to give over to Ben and Lee. Guys, thank you so much.
Thanks, Yolandi. So hey, good afternoon, good evening, good morning, everyone. I'm Ben. Lee's going to be talking as well, and we're going to be just talking a little bit about securing and monitoring BGP on MikroTik routers. As said, please, ask questions in the Q&A. Feel free to chat, and we'll definitely find some time to answer all your questions at the end of the session. So, what are we talking about today? Looking at BGP session monitoring on MikroTik routers. We want to know when sessions are down, right? We want to know when they're up. And it's also talking about enabling RPKI on your external BGP sessions, and also generating the deployment of strict IRR filters. It's great we're running BGP, but we also want to then make sure that the routes we're receiving are accurate and right and don't cause any issues or outages. We know misconfigured sessions can cause pain. And there's, it's really generally about having a healthy, clean, good network you operate. Why did we do this? Everyone needs a hobby. And Lee built his hobby network, his development network, his personal network, however you wanted to call it, using AS35008. And he's built this using MikroTik routers. Lots of reasons for selecting MikroTik. But wanted also to have lightweight operations, but also be MANAs compliant. So that means having strict filtering, RPKI, anti-spoofing, etc. But also to prove how easy it is to deploy all this without using, big vendor iron. And where tools don't exist, he's coded them. So what do you need? You've got MikroTik routers. What else do you need, perhaps? So you need MikroTik routers. You need those to be running ROS 7+, and we've tested this against 7.7 through to 7.11.2. They need to be speaking BGP as well. Clearly, if you're not running BGP, you can't monitor it. Need the API configured and accessible to your routers. And you also need the MikroTik Router OS API Python packages. Then you also need BGP Q4 installed on your management host. So I'm going to talk a little bit about BGP monitoring first, and then I'm going to hand over to Lee, who will talk about securing BGP. So BGP monitoring, all these scripts we're going to talk through today, they're all in GitHub, they're all open source. You can download them, you can use them. You can contribute back to the code if you feel like there's a feature or function missing or something can be done in a more elegant way. There's 2 scripts in the BGP monitoring collection to make this work, and that help you monitor your BGP session state on your MikroTik routers. And it's really important to call out here that MikroTik is still lacking BGP support in their SNMP implementation. So no way, unless you run your own scripts, to actually monitor BGP session status on these devices. And 2 scripts are the BGP mon script, which you can see listed on the slide. And then there's also the BGP mon print script, and we'll look at both of these in a little bit more detail now. So the BGP mon script, look at configured peers and compare them with items under the BGP session to see if they match. But also look at the status of sessions under the routine BGP session and alert you if any session isn't established. So essentially, We'll look at sessions that are configured, and we'll look at sessions established, and then alert. It can also send you an email with an output each time you run the script. If you specify an email address, maybe that's how you like to consume your alerts. And here's an output of an example output of what the script delivers. You can see here we've got BGP sessions that are showing as configured but not running, so not established. We've then got the second script in the collection, the BGP mon print. This script displays the sessions that are currently running on the router. Doesn't look at things which are in routing BGP connection that are not also in the session, so it shouldn't be used to monitor health. But if you supply the router IP, then up or down the script at the command line, it will show you the status, the status of the BGP sessions. And you can see example output here with sessions an IX with the Facebook or the Meta network, and you can see how they're up, they're established, and how long they've been up for, and the number of prefixes. So I'll hand over to Lee to talk about securing BGP.
Thanks, Ben. So now we've established that we've got some BGP sessions and we're monitoring them. It's time to kind of look at how can we secure these. And so as Ben talked about in the intro, there's a couple of different things that we need to do here, really. One part is RPKI, route origin validation, and the other piece is applying strict IRR filters to each of the peers. So essentially building a prefix list for your peer, having a programmatic way of applying that to the box. So let's have a look at what this looks like. So let's say this is a collection of scripts which will take your list of peers, it will generate the filters, and then it will push them to the router. So it expects you to have this installed into user share MikroTik IRR updater. You can change that. There's a bunch of config lines. This runs BGP Q4 for you. So essentially, there's a config file that we'll talk about in the next slide where you define your peers and their various AS sets. These set of scripts then run BGP Q4. They also run a bunch of other scripts to generate the filters themselves. And then we push them to the box. So essentially, you have to configure it. There are a couple of wrappers to run, and then you're good to go. One big thing here, though, is obviously you were talking about updating the configuration quite a lot. MikroTik doesn't have a way of managing the configuration like Junos or some other router OSs where you can just apply changes. So essentially what we're doing here is the script looks for changes on the box versus the configurations it's generated, and will essentially delete and replace the configuration. So if you do have a large number of peers, or you have peers that have really huge route sets, you are going to be making a lot of reads and writes to the box. So it is worth keeping an eye on flash and SSD wear on these machines. So configurations. So first of all, we have a routers.conf file. So essentially, this is where you define your username and password for the MikroTik API. Really simple configuration. The next one's your peers.conf. So this is essentially a comma-separated list of ASN and AS set pairs. So this is the file that gets read and runs BGP Q4, loops down through, and generates the prefix lists. The next one's sessions.conf. So this is essentially a comma-separated list of ASN, slug, and router IP. And we'll talk about what the slug is later on in this presentation. And this is used to build the actual filters. It ensures the right naming of them, ensures the policy chaining, etc. is all set up in the right way. So then we have a couple of scripts to run. So build prefixes.sh is essentially a bash wrapper that runs through the peers.conf, runs BGP Q4, also runs a piece of Python to do filter gen, which essentially builds the actual filters themselves, turns everything into the right policy, ready to push to the router. The next piece is push filters. So this is essentially the piece that calls another bit of Python, which actually connects to the API in your MikroTik box, does that compare, looks to see whether there have been changes based on what's built on your management host versus what's running on the router, and then does the needful, essentially pushes the configuration to the router. Run these from cron. I run the build prefixes one fairly frequently to catch prefix updates, and then I'm currently running the push filters one twice a day. Build prefixes can take a while to run. Obviously, it's pulling down from RR, the various AS sets. I have a couple of peers which are fairly sizable on an exchange in San Francisco, so it does take a little while to run. So slugs. So think of a slug like a short name. So I use these essentially to classify a group of peers who have the same policy attached. Really what we're looking for here is avoiding duplication of policy config. So much like you can use terms like next policy on a Juniper, you can use jump on a MikroTik. And so essentially what you can see here at the bottom of this example is an example of my Facebook configuration on SFMix. So SFMix is the slug in this case. And you can see here that at the end of these policy lines where you have prefixes, so take line 6356 here, you can see at the end it says jump SFMix import. So essentially what it's doing here is jumping to another policy to apply some other stuff. Essentially what you can then do is apply things like meds, local preferences, apply communities, like do all of your regular kind of traffic engineering that you're probably already doing in an import statement. It just allows you to have this at the very first part of the chain, so you can loop through the prefixes first and drop any prefixes you want to drop. So origin validation. So it's great to have prefix filtering. Obviously, people can still put the wrong thing in their prefix set. They can still advertise you the wrong stuff. So it's still really useful to have RPKI origin validation. For me personally, I'm running RPKI on all external BGP sessions. I'm not running prefix filters on my transit sessions. There's clearly no point in generating a filter with the entire internet in it. So I'm running prefix filters against peers and quote unquote customers, and then have origin validation as the kind of last resort on my transit sessions. You need to have access to a validator, ideally more than one for resilience. There are a whole bunch out there. RPKI client, Routinator, Cloudflare have one. I'm running these in Docker containers on my management host. And then configuring the router is actually really pretty straightforward. Everything's under routing RPKI in the web UI. And you can see here at the bottom, we have an example of a couple of different validators running in a group called validator. And the group name is important for your policy filtering later. I blanked out the IP address here to protect the innocent. But yeah, it's a pretty simple configuration, to be fair. So you need a policy to actually apply and use this origin validation. So you can see at the bottom of this slide here, we have an example of what the policy filter looks like. It's actually really very simple. Again, you can see on line 36 here, RPKI verify, and then this is the group name that you created when you added the validators to the configuration. So I have my group imaginatively called validator. And you can see here, it's a really very simple policy statement. If RPKI invalid, then reject, else accept. So essentially, I'm accepting RPKI unknowns and RPKI valids, but I'm rejecting invalids. And so we bring all this together with filters. Really, this is about chaining these filters together. So we have strict IR filters on peers and customers. We have RPKI validation on all external BGP sessions. And then we're using jump expressions in those filters to hop between them. So if we think about what that looks like here at the bottom, we have a peer-specific strict RR filter against the peer, which includes all of their prefixes. We then have a jump to go to a specific slug-based filter, which in the example I gave earlier is the SFMix import. That then allows me to add T communities, BGP communities. It allows me to change the local preference, set the med and all of those kind of fun things. Then it jumps to an RPKI import, which then does, as you just saw in the previous policy, accepts or rejects based on RPKI validation. And that's it. It's actually really quite simple. And so let's take a look at what this actually looks like. So here we have an example of Meta, Facebook, 32934 at SFMix in San Francisco. You can see here I'm applying the AS32934 specific import for SFMix here with that slug in there again. The filter then calls the SFMix import rather than accepting straight away. And you can see here I'm applying a bunch of communities. I'm setting local preference. There's a BGP med, and then we're jumping through to that RPKI import. And again, that's a really very simple filter that you've seen before. That then accepts the prefixes based on being unknown or valid, or rejects them based on invalid. And that's as simple as it is, really. It's actually dead straightforward. I think the most difficult piece of all of this was building the code to actually generate the filters and push them to the box. There didn't seem to be anything else out there. Happy to hear if anybody else knows of anything. Also really happy if anybody wants to contribute to the code and make it better. I would say this is very alpha, but it works. There's a bunch of networks using this, and yeah, it definitely fixed the problem for me. And so BGP process tuning is kind of the last thing. Obviously, we're generating new and tearing down existing policies, which does create a bit of churn. By default, BGP peers on the MikroTik box all share a single process, which does end up flattening in a single CPU core. My peering box is actually a 16 core, 16 gig of RAM, CCR 2116. It does have a bunch of CPU, and I was noticing when monitoring this that only one CPU core was being flattened every time I was updating the policies. Because obviously every time you change the policy, you're creating a route refresh. You can actually separate the sessions into their own process. Slightly increases memory usage, but it does help with CPU usage during BGP events. It essentially allows you to shard each of these into their own process, which can get spread across the CPU cores much more nicely. As I say here, particularly useful when you're doing the RR filters because of that route refresh, especially if you have a peer that has a ton of prefixes. And you can find this under the extra section of the BGP session configuration in the web UI. It looks a little bit like the diagram here. Essentially on my box, I'm setting them to alone. You can set them into groups. There's a whole bunch of different things. MikroTik's documentation on this is actually pretty good. It's just not very well known. And that's it. I think Ben and I are both known for talking really fast, so apologies. We've rattled through this really, really quickly. But yeah, any questions? Here are the GitHub links to the RR updating scripts as well as the BGP monitoring ones. In my GitHub repo, you can also find a Juniper version of the RR updating script, as I'm currently tinkering with Juniper to add to the network also.
Guys, this was probably the quickest tech days ever. Like, it was literally like 20 minutes.
Oh, yeah.
I think the PNDB one that I did was a similar speed.
It was a bit longer, but yeah. So attendees, please, do you guys have questions? We need to keep talking here. Or any comments, for Ben and Lee, please throw them into the Q&A for us or in the chat.
Equally, if there's no questions, please feel free to download the code and have a play of it and give it a go. And feedback, whether that's reaching out to us directly to let us know you're using it, or asking questions, or raising bugs in the GitHub. It would be great to know what people think.
Lee, you are muted.
Why'd I use WebFig as opposed to Winbox? No preference, really. This was my first foray into MikroTik when I built this network. I found the web config first. I use SSH for a bunch of stuff too. So, yeah, that's the only reason. There's no preference one or the other. You keep mentioning kind of large prefix amount. What do you consider large? I have AWS and Cloudflare, which are both, I think, maybe 50 or 60,000 lines long. I would consider those kind of large. I don't have any kind of tier 1 type peers with 300,000 routes, but 50 or 60,000 across 2 or 3 different peers between Akamai, Cloudflare, and Amazon. There's actually quite a few prefixes. For BGPmon, are there any plans to expose BGP statuses via Prometheus? Not for me personally. I don't use Prometheus, but if you want to contribute to the code, I would happily take a PR. Happily create a version that can talk to Prometheus. It's not something I've looked at though.
There's also a question in the chat
Yes.
for you.
No, they're not compatible with Router OS 6, sadly. Router OS 6 and 7 are actually really quite different. I don't have any boxes capable of running Router OS 6, although looking at some of the bugs I found in Router OS 7, maybe I wish that I did, but sadly not. How do you manage the vast amount of routes on the router, or does your config reduce this too? The config doesn't reduce it, no. I'm actually running full tables on all of my boxes, so I have multiple transit providers, multiple peering exchanges, so all of these boxes have multiple millions of routes on them at this point. I'm not filtering down to only defaults or anything similar.
Any last questions?
Have you do it to study issues getting prefixes advertised? What do you mean by advertised in your question there? Does the script also allow prioritizing of multiple routes? I think this is down to however you want to configure your policy. I have the same peer across multiple exchanges, but I do have meds set, so I am using some things to prioritize between different routes, I guess. This is all ultimately down to your TE policy. Really, all we're doing here is generating filters to accept or reject routes. The whole purpose, I guess, of the slug and going to the second policy is more to allow you to then customize what you want to do afterwards. So that's comes down to what you're doing for your TE today. Router OS 7 seems slow to announce prefixes out to peers. I completely agree. I have many problems internally with stuck routes and things being advertised between boxes. I had a reach out from Kentic fairly recently because I export my table to route views, and they were investigating a route that had been withdrawn from the routing table maybe 3 or 4 days previous, and my routers were still holding on to those. So there are a good number of bugs to be had in MikroTik, and I'm not convinced that they expect people to be running these with the full BGP tables, despite them being capable. But yeah, it's been an interesting journey building this for sure. It takes a long time to advertise routes to peers / transit and high load on the CPU. Yeah, it really does. These boxes don't have the best CPUs. I'm running a 16-core, 16 gig of RAM box on the edge. My core is less powerful, and I definitely see lots and lots of churn when a transit provider drops or I reboot a box without closing BGP first. Yeah, it's definitely been quite interesting. As I mentioned here, I have rewritten some of the IR updating scripts to work with Junos also. I actually have a MX204 sat on the floor next to me that's going to get put into the network soon. So I can see if I can get back to some normality of removing some of these bugs from my life. Using MikroTik hardware or Dell HP Supermicro. I'm actually using MikroTik hardware. I have 6 boxes in the network today, 2 in the edge, 2 in the core, and 2 as access. They're all MikroTik hardware, running Router OS 7.
I see Alex has his hand up. Alex, if you can, please put your question or comment in the Q&A section. Or it might have been a mistake.
Everybody's been really nice and letting us off the hook here, I think.
Yeah.
Maybe they also just woke up, so.
We just woke up. I don't know about all of you. It's 5:26 on the west coast of the US right now.
Oh, that's lovely.
Have you experimented with virtualizing MikroTik routers? This could potentially enhance workload management. Yeah, I totally agree. I haven't looked at virtualizing. I bought a bunch of these MikroTik boxes on Amazon actually, and haven't really looked at virtualizing. At the time, I had no servers there when I first built the network. I've then since introduced a bunch of Delkit to do management and a bit of web hosting. Ben and I host a friend's podcast. But no, haven't looked at virtualizing MikroTik on these as yet. Like I say, I'm toying with Juniper at the minute. I'm probably going to run some kind of dual vendor network because I really love to find bugs apparently, and we'll see how that goes with both Router OS and Junos.
Cool. Any last comments or questions for Ben and Lee? Are we all good?
I guess the one call for action again from us is download it. Let us know what you think. Let us know if it's useful. And yeah, love to hear feedback.
Yeah, definitely. My email address is in the top of all of the scripts. If you have any comments, questions, that'd be really useful. And we know of a bunch of networks in Latin America and other places that are running this. So it would be great to hear of some networks in your part of the world that are running this and find it useful.
I see there's a few questions around the recording. Yes, the session has been recorded and it will be made available. So we will send it out after this session, and it will also be listed on our website. All right, I think that is everything, guys. Ben, Lee, as always, thank you so much, especially for waking up so early for our South African people. We will now enjoy a nice cold beer while you guys work. So
we'll enjoy
guys,
a nice coffee.
I think so. Excellent. Thanks, Yolandi. Yeah. Thanks everybody for tuning in and listening, and for the great questions.
Yeah, thanks for having us.
Yeah, thank you so much. So attendees, thank you so much for joining. We will see you at the next session. And yeah, have a great rest of the week.